Welcome back to today's video. In today's video, we're going to be covering how to train an AI model, particularly taking a look at instance-based learning versus model-based learning. In the next lesson, we'll be discussing how to solve a particular problem in life expectancy versus GDP growth, how to solve a particular LLM problem using linear regression, and we're going to get into a particular example in the next video. But in today's video, I wanted to cover the main ideas behind the concepts behind these ideas. So when it comes to machine learning, generalization is an important aspect of it. We talked about how we have a training set. And what a system, what an AI, what a machine learning system is supposed to do is it is supposed to create a prediction based on a specific large set of training sets. It's supposed to generalize that training set. There's two ways to generalize a training set of information to a particular instance of a problem, a new instance of a problem, and that is instance-based learning versus model-based learning. So let's discuss the first one, and that is instance-based learning. So in instance-based learning, remember in both of these types of learning, we're given a large training set of information, and again, the machine learning model is supposed to generalize from that training set. And there's two ways to do that. The first way is by instance-based learning. In instance-based learning, the system learns by remembering examples, and when it sees something new, it looks to the most similar examples it has seen before and bases its predictions on them. And so for this one, it's less of determining a formula or a rule in order to solve the problem. It's more of taking a look at how similar um, the the instance that we're being given in this particular case is to the previous instances. So in the previous past examples. And so the system may use a similarity test in order to see how similar a new instance is to previous instances that it has been given in the training set. And so this is called a measure of similarity. A measure of similarity is a function that quantifies how alike two objects are based on their features or attributes. And so you see here this function, just generically, we have here a function s that accepts two arguments, x and y, and it returns some real value. Now this real value that it's returning simply indicates how much similar the two objects x and y are to each other. Okay? And so if we have, let's say, a new instance coming into the model, we can compare this instance to, let's say, one of the instances in the training set. And when we compare those two values, we can see how similar the new instance coming in and one of the instances in the training set, how similar they are. And we can output a value of r, which is a degree of similarity. And again, we're just defining this like abstractly. We're not giving a specific function, but this is the general idea behind it. And obviously, a degree of resemblance indicates a higher degree of similarity. And so we see an example here. We talked about spam emails when we were talking about supervised learning. We talked about spam emails and how we can remember label those emails as being spam or non-spam, and we could use label data. But let's go back to that idea. And so in the example here, it says given two emails, X and Y, X being a labeled spam email in the training set. So this is labeled supervised learning, right? Supervised learning. It's X is an example of something that's been labeled as a spam email, and we already include that in our training set. We can use the similarity function S, similarity function S, to count the number of words that the spam email in the training set and the Y, which is the new email coming in, how many words they have in common. And based on this, the system could flag the email if it has a high enough number of words in common. In other words, if it has a high enough degree of similarity. And so the Y in this case would be the new instance coming in, and the X would be a labeled spam email. And we could do a similarity test on that. And so depending on the value of R, if the value of R is higher, that would mean that it most likely would be a spam email. And so that's how we could use a similarity test, not necessarily defining a rule or a formula, but it's or even an algorithm, but it's mainly just comparing it to previous instances of that occurring. And so this is instance-based learning. This is one way that we can do generalization. Another way, this is a more common way, is model-based learning. So we're going to go over the main idea behind model-based learning, but in the next lesson, we're going to use a specific example and kind of train our own model, talk about how to train a model from a more mathematical sense. Okay, so we'll be talking about that in the next lesson. Maybe I'll introduce it in this tutorial, and then we can talk about it in the next tutorial, in tutorial number 4. So model-based learning is another way of generalization. The definition here is a way of generalization in which a set of examples are used to create a model. That model is used to make predictions. And so you can see here in this picture right over here, we have some triangles and we have some squares, and you see the x there is a new instance there. And so we notice here the model is defining a rule here in this particular case by grouping it in that particular instance. So it defines a rule rather than just comparing it to previous instances in the trading set. So it's defining a rule rather than just comparing it to previous instances. And in the next lesson, we'll get into a particular example. So let's go ahead and just get into the brief introduction. I'll cover this in the next lesson. But we're covering the basic idea where we're going to be comparing GDP growth to life satisfaction. So basically looking at the GDP per capita and comparing that to life satisfaction in general. And we're going to take a look, is there a correlation, first of all, in between those two numbers? Well, here we have a chart here comparing different countries, Hungary, Korea, France, Australia, the United States of America. And you see the GDP per capita along with the life satisfaction. And when we plot that data, we can see a general correlation here where we see that as the GDP per capita on the x-axis increases, the life satisfaction on the y-axis increases. That's just an observation based on the data that we are observing. All right. And so we notice that there's a trend line in between this. So what we're going to do is we're going to create a function. Now, our idea is to create a function. And we'll get into more of the mathematical portions of it a little bit later. But the idea here is that we're going to create a trend line, right, based on the GDP per capita. So we can model this as some sort of a linear function because you can see here that there is some linear nature towards this growth line, right? So we're using GDP per capita as the only determiner, right? As the only determiner, right? And so it's going to be like the x value, the input variable coming into a function. This is called model selection. So when we're choosing which attributes we are going to use to determine the output, in this case, the output would be life satisfaction, the input would be GDP per capita. When we are determining which attributes to use, this is called model selection. Okay, model selection. Let me just fix the spelling of that there. Model selection. Okay, so model selection are the attributes that we're using for that. Okay, and the equation that we're going to use here, and we'll get into more of this in the next lesson, in the next tutorial. But the equation is going to be life satisfaction. Remember, that's the output. So we're setting that on the left-hand side is the y in that case, is equal to the intercept or the starting value plus the slope times the GDP per capita. Okay, the GDP per capita. Now, in this case, the GDP per capita, GDP by the way, is just the gross domestic product of an economy. It's how much an economy produces on a yearly basis, and we're dividing it by the number of people within that particular economy, right? Now, obviously, the amount of money that's being distributed to each person in an economy will not necessarily be the same because if one person has a higher net output than another person in terms of the money net output, then that person, it's not going to be an equal distribution, right? It's not the GDP divided by the capita is not an equal distribute. It's not going to be equally distributed to every single person in the country. But this is just a generic, a very generic model that we're creating here. Okay, but we see here that it's equal to the intercept, the starting value, plus the slope times the GDP per capita. Now, why are we considering the intercept? Notice here that whenever you have something in math, and you have an intercept plus slope times some value, typically speaking, what that means is that when the slope is set equal to 0, what exactly, or the GDP per capita, when the GDP per capita is set equal to 0, that is going to be equal to the life satisfaction. So let's say a person had a GDP per capita of zero. So they literally had no money at all. Is there going to be some form of, does that mean their life satisfaction is going to be 0? No, right? And so there is a default life satisfaction without any GDP per capita being considered. With a 0 GDP per capita, they make literally no money, regardless of what the slope is. If they make literally no money, what is going to be their life satisfaction? Well, that's going to be the intercept or the starting value, right? And so that's something that we have to consider. Plus the slope, right? The slope. And so the slope is something we need to determine for our machine learning algorithm. And that's what we're going to be talking about. And so in the next lesson. So the function really has 2 degrees of freedom. We have 2 degrees of freedom, meaning that we can choose 2 things. We can choose the intercept or the starting value, and we can choose the slope, right? Those are 2 things that we can choose. The GDP per capita is not a degree of freedom. It is simply an input variable. And so going back, let's say in calculus, you have f of x equals mx plus b. In this case, m and b are 2 degrees of freedom. X is not a degree of freedom. X is simply an input variable. But what our machine learning algorithm is going to do is we are going to determine, based on the data that we have been provided, what is that intercept, that starting value, and what is that slope? What is that slope that we should choose in order to get the best